Hey everybody, this is Mr. Ainsworth again, and we are going to get into how to graph systems of inequalities here. And so before we do though, you need a pencil, all kinds of red pens. Take out at least 4 color pencils, take out a highlighter, you need all that equipment, take out a ruler. Okay, so pause the video and get all that out, and also take out section 6.5 in your notes right here, section 6.5 parts 1, 2, 3, and 4. We did them back in the previous unit. Here's section 6.5 part 1, how we graph linear inequalities in slope-intercept form. Notice the title, slope-intercept form. In part 2, we went into standard form when we talked about how to graph inequalities in standard form, so check this out. And then in part 3, we talked about how to graph horizontal and vertical lines and inequalities in part 3 here. And in part 4, well, we did a drill on how to graph linear inequalities in slope-intercept form without using test points, just by knowing the boundary line rule. So if you get section 6.5 parts 1, 2, 3, and 4 out and you have them to your side here, this is going to be easy because I'm not going to do anything new. What I'm going to do is apply what you know. Okay, so pause the video right now and take out section 6.5 parts 1, 2, 3, and 4. Have them side by side with this, and we're going to use all the skills that we learned in those lessons and apply it to systems. Okay, now speaking of that, let's talk about the definition of a system here, okay? Now a system, just like you did before with equalities, is a system as 2 or more, it could be 3, 4, 5 inequalities, as you're going to find out here, all right, is 2 or more equations or inequalities solved simultaneously on the same graph, where the solution is a point or a set of points, in this case it's a set of points, that satisfies both equations, okay, or all the equations. Visually, it is the intersection. Let's highlight this. Visually, it is the intersection of the regions in the linear inequality system. That is the key aspect here, okay? It is the intersection of the regions. All right, intersection. When I say intersection, write down overlap. You'll understand that when I start with the systems here. Okay, if there's no intersection, then there is no solution, just like in any system. They have to intersect. Whether they're equations or inequalities, you're always looking for the intersection. And in this case, because they're regions, all right, you're looking where they overlap. So let's start off with a simple system in slope-intercept form. This is section 6.6 in your textbook, by the way. All right, section 6.6. So you can open up your book as well and teach yourself. You can read everything and verify everything I say by reading your textbook. Oh my God, novel concept. So take that out and have it open too. So have your notes out, book out, all the tools out. Be sharp, ready to go. All right, so the very first thing we look at here is the system here. We got y less than x divided by 3 plus 2. Okay, it's in slope-intercept form. Y is less than mx plus b. This is in slope-intercept form. I took an easy one here to begin with. And we have to understand the basics here. Now, check this out. I see less than. Look at the inequalities. Less than versus greater than or equal to. When I see that, I know that we have a dotted boundary line and the solutions are below. Dotted boundary line, BL stands for boundary line, and the solutions are below the boundary line. Okay, you know that because we talked about this in our previous lessons. Let me take this out. Here's section 6.5 part 4. Look at all the boundary line rules. Look at the solution region rules. Okay, if it's less than or greater than, it's dotted boundary line. If it's greater than or greater than or equal to, it's above. Less than or less than or equal to, the solutions are below. Okay, and it's all right here. We've done all this before, but it's been a few weeks. And so what you need to do is have this all handy here. Take a look at all your previous work and apply it. Now this right here can be written as 1/3 x. So the slope here is 1/3, which means we're going to go up 1, right 3 from the y-intercept. And the y-intercept right here is 2. Okay, I'm going to write it as a point because it is a point. It's called the y-intercept. All right, so it's on the y-axis here. And we're going to start at 0,2 and use the slope of 1/3. So I'm going to color code everything. I'm going to put this first one in red. All right, so we're going to start at 2. Right here, we're going to go up 1 and right 3 from that point. So we're going to go up 1, right 3, plot a point, up 1, right 3, and keep repeating it until you're off the grid. And then reverse it and go down 1, left 3, down 1, left 3, down 1, left 3 until you're off the grid. Okay? Now do this in pencil, unless you want to just make a dotted line. I do it in pencil always, and then I just kick in my eraser here. All right, and you make it dotted. Okay, very, very simple. It's a dotted boundary line. Now, because of the solutions, or it's less than, the solutions are below. So we're going to graph below that boundary line. Don't use your highlighter until the very end. Okay, so I'm not going to write down all the boundary line rules because I am assuming that you guys did what I said and took out your 6-5 part 4, all your previous work here, and write down and you have all your rules to access. I mean, just read your notes, right? Use your notes to your advantage. It's less than, so it's below. It's less than, so it's dotted. Very simple. So this is y less than 1/3 x, okay, plus 2. That's first inequality in red. Next one I'm going to put in blue, all right, just so that you can see the difference in the graphs here, and we can see the intersection or the overlap real easily. Okay, so color code. It's y greater than or equal to, so I know that it's going to be a solid boundary line, all right, and greater than means that the solutions lie above. All right, so we start graphing at the with the slope. So the slope's -1/2, which means down 1, right 2, and the y-intercept right here is -1, or 0, -1 as a point, or as an ordered pair. All right, so we're going to plot 0, -1. Notice in blue now. Okay, I'm switching colors so you can see the difference. All right, and then I'm going to go down 1, right 2. So down 1, right 2, down 1, right 2, and keep repeating it. All right, reverse it. Go up 1, left 2, up 1, left 2, up 1, left 2. No problem there. Now make it solid because it has an equal to on the inequality right there. It's not greater than, it's greater than or equal to, which means the solutions are on the line. That's what solid means, okay? Now the solutions are above because of the greater than. So they're on the line and above. So graph above. Don't use your highlighter till the very end. Okay, so the question is, where's the intersection or the overlap? Because that's the solution. Solution is where the blue region overlaps the red region. When any two lines meet, okay, they form 4 regions. So I'm going to call this region up through here region 1, this one region 2, this region 3 using Roman numerals here, and this region I'm going to call this region 4. Okay, right here 4 using Roman numerals. When any two lines meet, they divide the plane into 4 specific regions. All right, and we would figure out which region is where they overlap. Now, if you look at points in region 1, like this point right here, it's in the blue region, so it satisfies the second inequality. Okay, not the red, but the blue. So it satisfies the second one and not the first one. Okay, remember it's red is down, okay? So this point right here is in the blue, this one's in the blue. All these points are in the blue region. So all these points in region 1, okay, all of these, okay, and there's an infinite number of points here, satisfy the the second inequality in blue, but not the second one, okay? Now, the points over here in region 2, this point, this point, this point, this point, this point, all these points right here, they're not in the blue region, they're not in the red region, so these points don't satisfy any of these inequalities, so they're definitely not solutions. I mean, you have to satisfy both inequalities, not just one of them. And then the points down here in region 3, well, this point is in the red, that's in the red, so it satisfies the first inequality up here. All of these points in region 3 are solutions to the only first inequality here. We want to find the points that satisfy both, which means they have to be in the intersection or the overlap. So in region 4, this point, this point, this point, all of these, in fact, let me highlight it here, all of these points in this yellow region satisfy both inequalities. It's where the blue and the red overlap. It's called the intersection. Okay, so we call this the solution region. Okay, it's the solution region of not just one of the inequalities, but of both. So it's the solution region of the system. Okay, so what you do is you graph each individually separately, color code them to make it easy to see and visualize. All right, and then wherever the colors overlap, okay, wherever they intersect or overlap is the solution to the whole system, which means both the inequalities. All right, these points satisfy both inequalities. Okay, all of these points satisfy both, better spell that correctly here, both inequalities. Okay, and because of that, the yellow region is the solution region. So look at the yellow region, all right, for the solutions. So your goal is to find out where they intersect, where they overlap in any system. I don't care whether it has 2 inequalities, 3 inequalities, 4 inequalities. Just look at where they overlap and highlight it, and you got it. Okay, any point in that yellow region satisfies both the inequalities, not one but both. And I repeated that about 10 times because that was important. Okay, now the only thing you need to do is get some experience, get good. You have to know which lines have slope, which ones don't, which have horizontal or vertical boundary lines. You got to get used to that. And so that is why you should have parts 6.5 part 3, okay, part 3, because this is where we graph horizontal and vertical boundary lines. I mean, look at all the examples that we have here. Okay, so use that to your advantage. So this one here, the first inequality in system 2, okay, it has slope. Slope's -2. Okay, I'm going to put this one in red. All right, slope's -2 or -2/1, which means down 2, right 1, from the y-intercept of 0, because it has a y-intercept. You don't see the number, so it's 0. Okay, b is 0, or 0, 0 as a point. All right, and I can already see also from right here that, and looking at the inequality here, greater than versus less than, I can already see that it's going to be dotted and above. Okay, so always predict, okay, how the graph looks. Okay, it's going to be dotted and the solutions are going to be above the boundary line. Okay, right away. And again, go back to your lesson notes on section 6.5 part 4 and look at all the boundary line rules. Okay, we did these many times before, 3 or 4 weeks ago. Well, let's do it again today, right? So have your notes handy. So here we go. We're going to plot 0, 0. We're going to go down 2, right 1, down 2, right 1. Go ahead and repeat the slope many times. All right, and then it's going to be dotted, so we'll use our eraser here in a minute. Okay, so there we go. We got a boundary line right there. Let's make it dotted though, because it's strictly greater than, so solutions do not lie on the line. Okay, they're off the line, so the question is where? Well, above, because it's greater than. So go above. Okay, so this is y greater than -2x. Now the next one, we'll put this one in blue. Okay, now y greater than 4. So focus in on the y-axis. So that's the vertical one. So find 4 in the y-axis is right here. Okay, now you want y less than 4. So that's not included. 4 is not less than 4, so that y value is not included. But all the values less than 4 are below this boundary line, which means we have to have a horizontal boundary line. Okay, all the y values below this, I'm talking about any point below this horizontal line, okay, has a y coordinate that's less than 4. Up here, the y coordinates are greater than 4, like 5, 6, 7, and 8. I mean, just visualize it. Here's 5, here's 6, and here's 7. All the y values above this horizontal boundary line are greater than 4. So graph below. Use your common sense. Okay, so where do the regions overlap? Well, let me see. You got region 1 here. You got region 2 here, 3 here. Oops, that's not 3. That's 3 in Roman numerals. Okay, and this is region 4. Okay, well, region 1 is only the red. Region 2, there's nothing. Okay, these points in here don't satisfy either inequality. Region 3 is only blue. And region 4 is blue overlapping the red. All right, so we want to graph in through here. This is your solution region right here. Okay, not of one line, but of both inequalities, okay? Why? Because all these points satisfy both inequalities, because it's in both regions. Not one, but both. So it's the solution region to the system, which means it satisfies both lines. Excuse me, both inequalities. Okay, so you saw a horizontal boundary line. This one's horizontal. Okay, well, let's take a look at the other cases, right? Because they're sloped. There's positive slope, negative slope, zero slope, like this horizontal boundary line right here. This one's horizontal. And guess what? There's vertical too, which means it doesn't have slope. So let's take a look at the differences between systems 2 and 3. Now here you got to isolate y first. Okay, so let's bring it off to the right. So we got 2x minus 3y is less than negative 6. Let's subtract 2x here. All right, always add the opposite first. All right, and we get negative 3y is less than negative 2x minus 6. Now keep in mind when you divide through by negative 3, all right, you have to switch the inequality. All right, I'm talking about this one here, from less than to greater than. Switch the inequality when you divide by negative. So you get y greater than 2/3 x plus 2. So you can see the slope and the y-intercept right there. And know that it's going to be dotted and above. Now if I'm moving too fast in the video, this is a video, right? So use it to your advantage and pause and play as much as you want. Okay? I'm serious. I watch videos myself all the time, and I pause and play when I need to. So do the same thing. All right. So we're going to plot 2 first, okay, the y-intercept, and we're going to go up 2, right 3, and repeat it. All right, up 2, right 3, and then reverse it, down 2, left 3, down 2, left 3. Okay, and it's going to be dotted and above. So take your straight edge out. All right, and then go ahead and make it dotted. Why? Because the solutions are not on the boundary line here. Okay, and graph above. Okay, because it's greater than. So we go dotted and above. So the first one's in red. Now the next one, this one here, is going to be in blue. Okay, so I'm going to find negative 3 on the x-axis, which means it's right here. There's negative 3. And look at the x-axis now, the horizontal one here. All right, where are the x values greater than 3? Excuse me, greater than negative 3. Okay, and if you just use your common sense, numbers get bigger to the right. So we're talking about this way. So all the x values to the right of this vertical boundary line, okay, all of them are greater than negative 3. So label it x greater than negative 3. It's a vertical boundary line. All right, and you know that because guess what? We've done it before. All right, take a look at this here. In our 6.5 part 3, we did plenty. Okay, look at these. X equals 4 was a vertical boundary line through 4. X greater than negative 2 was a vertical boundary line through negative 2 and to the right. X less than or equal to negative 1 was a vertical boundary line and to the left. We did it plenty of these. What you need to do is review and get good. Okay, that's what you need to do. All right, and now you find the intersection. And the intersection, my friends, is where they overlap, which is obviously in here. Blue overlaps red in through here. So this is your solution region to the system. All right, so solution region. There we go. The only thing you need to do is get good. I mean, some lines have negative slope, some have positive slope, like this example 3 just has positive slope. In example 2, it had negative slope. It had a horizontal boundary line. Example 3 had a vertical boundary line. You got to put all your skills in. All right? So use your notes to your advantage and get good. Okay, so let's practice. Now I want you guys to pause and play. All right, so pause and play through the rest of the video. All right, pause the video right now and try it, and then press play when you're ready. I mean, pause and play. Okay, if you haven't done it, don't wait for me. All right, let's give it a shot. So here we go. First one's going to be in red. So y greater than 0. So here's the y-axis. Here's 0 right here. All values that are greater than 0 are above this horizontal line. All right, so this has to be a horizontal boundary line because any point above this horizontal boundary line has y greater than 0 as a coordinate. I mean, think about it. This point right here is 2, 5 has a positive y coordinate. Points below this boundary line have negative y coordinates. Y greater than 0 means that it must be positive. Okay, there's your red one. Okay, now let's switch to blue. X greater than 0. Well, focus in on your x-axis right here. values that are greater than 0, like 1, 2, 3, 4, 5, all these values to the right of 0. So this suggests that you have a vertical boundary line. So right here, this suggests x equals 0. It's a vertical boundary line through 0. All the points to the right of the y-axis have an x-coordinate of 0. Excuse me, x-coordinate greater than 0, which means it's positive. Over here on the quadrants 2 and 3, these have x-coordinates less than 0. Okay? Okay, now here, the slope here is -1, and the y-intercept is 8. So we're going to start up here at 8 on the y-axis because it is a y-intercept, as you guys know. So we go down 1, right 1. So step it out, down 1, right 1. And if you step it out correctly, you should end up at 8 on the x-axis. Okay, now draw your line. All right, and make it dotted. Okay, because the solutions are not on this boundary line. Come on, computer. It's going a little slow here, guys. That should be a dotted boundary line. There we go. Now it's working. Okay, so it's a dotted boundary line, and the, let me see, it's less than, so this is dotted. And below, the solutions lie below it. So go below. So this is y less than negative x plus 8. So where do they overlap? Where do they intersect? Okay, where do all three colors overlap? So get out your highlighter and highlight the region where they all three overlap, which is in here. It's this triangular region here. So that, my friends, is your solution region. Okay, you just have to get a lot of practice, get good. All right, let's do another one, because 4 examples is not enough to master it. I've done thousands and thousands. That's the only reason why I can do this so easily. It's not because I'm smarter than you. All right, it's just because I have a whole lot more practice than you. That's all. Okay, so one more time, pause and play. Pause the video, press play when you're ready. Okay, let's graph the first one. Okay, just like the previous one, y is greater than 0. So here's 0, and the y values that are greater than 0 are above this axis right here. Okay, so there's y greater than 0. Okay, switching colors again like I always do. Blue, x greater than 0. All x values that are greater than 0, like 1, 2, 3, 4, 5, and 6, and so on, lie to the right of the y-axis. So we have a a vertical boundary line, dotted, by the way. Okay, x greater than 0 is a dotted boundary line through the y-axis. Okay, and this one here, slope's -2 over 1, y-intercept at 8, 0, 8. So start at 8. Okay, we go down 2, right 1, and then step it out. If you did it correctly, you should intersect at 4 on the x-axis. Okay, so let's draw a dotted boundary line. Okay, and all values that are less than this line lie below it. All right, look at that. It says less than, right? So it's dotted and below. I keep on repeating myself here, so hopefully you guys are cluing into the obvious on what's going on. Okay, after 5 examples, I've done the same thing 5 times in a row, and hopefully you see some connection here. So the solution region is that triangle, that yellow triangle in there. Okay. Okay, last one. Okay, y greater than 0, above the x-axis, always up here. Okay, any y coordinate, if it's greater than 0, has to be above this horizontal boundary line. Okay, that's in red. X greater than 0 is to the right of the y-axis. Any point to the right of the x-axis, all right, is greater than 0. It's positive. Okay. Over here, the x values in quadrants 2 and 3 are negative. Over here in quadrants 1 and 4, they're positive. Okay, and this one here starts at 6. Y-intercept 6. Slope's negative 3/2. Down 3, right 2. So down 3, right 2. Down 3, right 2. Okay, and it's dotted in below. Okay, once again, like this. So that's y less than negative 3/2 x plus 6. All right, and where do the L intersect? It's in this little teeny triangle in here. Okay? And that's how you do it, my friends. The only thing you need to do is get some experience. So thinking of that, okay, now it's time to do your homework. Okay, that's HW for homework, okay? Do numbers 1 through 8, all right, and check your work. Because I give you the answers to everything. So check your homework with the answers provided, okay? So do your best, okay? You did 4 here, there's another 4 here, and then attached are the answers. So check your work as you go. And again, there's a video, so if you need to refer back to anything, be my guest. Pause, play, rewind, and take yourself through it. And again, get organized. All right, learn how to use your notes to your advantage. And I'll see you in my next lesson in linear programming, okay? This is all based or prep for what's called linear, okay? Programming is the application, okay, of linear inequality systems, okay? We'll talk about that in my next lesson. I'll see you then. This is Mr. Ainsworth. I'm out of here.